All right, everyone. In this video, I'm going to show you how to determine conditional probability with Bayes' theorem. In the neon sign here on the title slide, as you can see, this is the formula for Bayes' theorem. It's the probability of event A happening given event B. That's equal to the probability of B happening given A multiplied by the probability of event A over the probability of event B happening. So let's dig into this. Why is this important to you? Well, what Bayes' theorem does is it describes the probability of an event based on prior knowledge of conditions that might be related to the event. For example, if cancer is related to age, then using Bayes' theorem, a person's age can be used to more accurately assess the probability that they have cancer than can be done without knowledge of the person's age. And if you fail to use this, it can definitely lead to faulty statistical evaluation. Now let's take a look at an example of this. Okay, now let's say you have 1% of women between the ages of 40 to 50 that actually have breast cancer. And of women who test positive for cancer via mammogram, 90% of them actually have cancer while the other 10% don't, which would be what's called a false positive. Given a woman has just tested positive for cancer, what is the probability that she actually has it? And this is where we can use Bayes' theorem to give an accurate assessment of this conditional probability, okay? So once again, the probability of A given B is equivalent to the probability of B given A multiplied by probability of A all over the probability of B. So if we say that A is the woman having cancer and B is the woman testing positive for cancer, the probability of A, of the woman having cancer, is 1%, right? Just like we said in our initial description. Now the probability of B is going to be 1% times 90%. Okay, so this would be the 90% that actually have the cancer plus the 99% times the 10% who don't, and mathematically that works out to 0.108. Okay, so the probability of B given A is 90%. Therefore, you multiply all this out and divide it, and you get the probability of A given B is 90% times 1% divided by 0.108, and you're left with 8.3%. So turns out that there is only an 8.3% probability that this woman actually has cancer, which actually might be a more positive outlook if you've just been diagnosed with cancer and you're initially thinking like, wow, the odds seem pretty high that if the test shows that I have cancer, that I actually have cancer. Well, it's really only 8.3%. So this is how you can use Bayes' theorem to use statistics and probability to give you some information that you might not otherwise have thought of. Okay, so thanks for checking this out, and I look forward to seeing you in the next video. Take care.